Let's discuss the electrical wiring setup, grounding, and power consumption, focusing on key aspects to ensure safety and efficiency. The first question addresses the wiring of the house breaker box. Based on the provided details, the house breaker box seems to be wired correctly. The connections to the neutral and ground bus, along with the presence of a tie bar and panel bond, align with standard electrical code requirements. These components ensure that the electrical system is properly grounded and that fault currents can be safely directed to the earth. The grounding system is a critical safety feature in any electrical installation. It provides a low impedance path for fault currents to flow, which helps to protect against electrical shock and minimizes the risk of damage to equipment. A properly grounded system also ensures that circuit breakers and fuses can effectively interrupt the flow of current in the event of a fault, preventing overheating and potential fires. The second question concerns the need for grounding the indoor load center, even when there is a ground at the street. The indoor load center should indeed be grounded, irrespective of the presence of a ground at the street. The purpose of the ground rod at the house is to establish a low resistance path for fault currents to flow to the earth, independent of any other grounding points. This additional grounding provides redundancy and ensures that the electrical system remains safe, even if there are issues with the primary grounding connection. The ground rod helps stabilize the voltage to earth, reducing the risk of electrical shock. It also helps to minimize electrical noise and interference, which can be particularly important for sensitive electronic equipment. To properly ground the indoor load center, a ground rod should be installed outside the house, typically driven into the earth to a depth of at least 8 feet. A heavy gauge copper wire should then be connected from the ground rod to the grounding bus bar inside the load center. This connection should be made using approved grounding clamps and connectors to ensure reliable and low resistance connection. The third question addresses the high kilowatt usage from the 220 lines, particularly when appliances like dryers are running. The high kilowatt usage from the 220 lines is primarily due to the fact that these appliances draw a significant amount of current. Appliances such as dryers, stoves, and power tools are designed to operate at high voltage levels, which allows them to deliver more power for their intended functions. When the dryer is running, the heating element draws a large amount of current to generate heat, which is why the meter disk revolves more quickly. The power consumed by an electrical appliance is determined by the formula power equals voltage times current, or P equals volts times amps. In the case of a 220 volts appliance, the power consumption can be substantial, especially if the appliance is used frequently or for extended periods. To reduce high kilowatt usage, one should consider using energy-efficient appliances, minimizing the use of high-power appliances during peak demand times, and ensuring that the electrical system is properly maintained. Regular maintenance can help identify and correct any issues that may be contributing to increased power consumption, such as loose connections or faulty components. The fourth question asks whether the house load center is considered a subpanel, even though it does not receive power from the shop's panel. The house load center is not considered a subpanel because it is directly connected to the incoming power from the street and does not receive power from the shop's panel. A subpanel is a distribution panel that receives its power from another panel, typically a main panel. In this case, the house load center and the shop panel are both independently connected to the main service entrance, making them separate load centers rather than a main panel and a subpanel. Understanding the difference between a main panel and a subpanel is important for ensuring that the electrical system is properly configured and that all components are correctly sized and protected. Subpanels require specific wiring configurations, including separate neutral and ground buses to prevent ground loops and ensure proper grounding. The incoming power from the street typically consists of 2 hot wires, a neutral wire, and a ground wire. These wires are connected to the main service entrance, which is usually located near the meter. From the service entrance, the power is distributed to the various load centers and branch circuits throughout the house and shop. The size of the service entrance and the capacity of the load center should be carefully selected to accommodate the anticipated electrical load. It is important to consult with a qualified electrician to ensure that the electrical system is properly designed and installed in accordance with local electrical codes and regulations. In summary, the house breaker box appears to be wired correctly. The indoor load center should be grounded regardless of the street ground. High kilowatt usage is due to the current draw of 220 volts appliances, and the house load center is not a subpanel.